Okay, good morning. So today we're going to move into section 11.6, which is going to be something just a little new for sure. We're going to find the area of regular polygons. So that could be any hexagon, octagon, pentagon, decagon, but regular, remember, means all sides and all angles are congruent, okay? And so this is a little different, but I think once you get the hang of it, you're gonna feel like it's not too bad. Okay, so if we have a circle here, let me just draw us a picture. This probably isn't gonna be perfect. And I'm gonna put 6. And we're gonna say that this regular hexagon is inscribed inside the circle. Remember, that's what it means to be inscribed, okay? So this is kind of the picture that we're looking at. Today we're going to learn how to find the area of the inside of this hexagon, okay? So the center of the polygon and the radius of the polygon are the center and the radius of what the circle would be, okay? Meaning, if you put a point here in the middle, this is going to be the center. That's going to be really critical to what we're doing today, okay? Remember, a radius goes from the center of a circle to any point on the circle. So if I go to any vertice, like if I come right there, that's a radius. And if I come right here, that's a radius, okay? One of the things you're probably going to notice is that this obviously makes a triangle, and if the two sides are congruent, then it makes an isosceles triangle, okay? We could obviously draw radii all in here, but we're going to be focusing today on this triangle, and then that's going to help us to find the area. Okay, so remember that your radius is always going to be drawn to a vertex. Just pick one, sometimes two. We'll probably draw it to 2, but that's where you have to draw those 2. All right, this is a new thing, this definition in this box here. The distance from the center, so from the center to any side of the polygon is called the apothem. Kind of a weird word, okay? So I'm going to get a different color here. So if I go from the center straight down here to the side, this is the apothem. Well, because this is an isosceles triangle, this is going to be a right angle there, and it's going to split that into 2 congruent triangles. So we're going to label that A for apothem. And then our last definition here, a central angle. This is going to be really important to our lesson today. A central angle of a regular polygon is an angle formed by 2 radii drawn to consecutive vertices. So this entire angle all the way across there, that is what we call a central angle. Okay? And to get your central angle, you're just going to take 360 divided by your number of sides. Okay, so just kind of to show you, a lot of times we're not even going to draw, like if it's talking about a hexagon, I'm not even going to draw the full hexagon. I'm going to draw this whole triangle. So I'm just going to kind of redraw this. And this is going to be critical to you being good at this. This is a radius. This is a radius. What's this called? That's your apothem. This whole thing is a side of your polygon. And then this up here is the central angle. And we're going to focus on the details of this triangle over and over and over and over again. So the formula itself looks extremely simple. It's called area is 1/2 apothem times the perimeter. So you're going to take 1/2 times this apothem, this height of this isosceles triangle, times the perimeter of the entire hexagon. So that's where your side length is going to come in, because every single time you're going to have to find the perimeter of your polygon. This time we're like kind of focusing on a hexagon. Sorry. Okay. I'm moving along here. All right, so this is going to just kind of get us going slowly. So it says in the diagram, ABCDF is a regular hexagon that's 6 sides inscribed in circle G. Find the angle measure of EF So they want us to find EFG, they want us to find EGH, which is that little guy, and then HEG, okay? So if you can kind of see this triangle, it's kind of tilted over here. All right, so the first thing I want to do, this is 90, obviously, right? So I'm going to go right here, and I'm going to do 360 divided by 6. Now, again, why am I dividing by 6? Because I have 6 sides. So that whole angle is 60 degrees. Okay, but they want EFG, which is this little angle down here, right? So if the whole angle is 60, so this is an isosceles triangle, right? If this whole guy is 60, what would each of these pieces be? They would have to be 30. And since these are 90, these would have to be 60. So when you kind of separate it all like that, then it's pretty easy. Okay, EFG has to be one of my 60-degree angles. EGH is one of my 30-degree angles. And HEG is one of my 60-degree angles. These aren't always going to be 30s and 60s, but that's just kind of how this one worked out. All right, example 2. A regular octagon has 3 centimeter sides and a radius of 3.92. What is the area of the polygon? So every single time, I'm going to come in here and I'm going to make my triangle. And really, you don't even have to draw the octagon if it's not there, but this triangle is going to be critical, okay? So just as a reminder, every single time on the triangle, you've got, this is your side, this right here is your apothem, radius, radius, and then that is central angle. So we're going to be doing that over and over and over again. So I know my side is 3, and I also know that my radius is 3.92, okay? It says, what is the area of the polygon to the nearest tenth? So it gives you steps on this one. Find the central angle. I mean, that's going to be key. So I'm going to do 360 divided by 8, which I believe gives me 45 degrees. Okay, and so I like to usually draw my triangle out here and then split it in half. So I've got this, this is 45, this is 3, this is 3.92. Now remember, my apothem is my area is 1/2 apothem times perimeter. So on this one, I'm really just looking for that apothem. My perimeter is going to be, there's 8 sides, and I know they're all length 3. So that part was pretty easy on this one. Okay, then I have to cut this triangle in half every time. So every single time I cut it in half, this now would not be 3, sorry, that'd be 1.5. This would be 3.92. This is my apothem, and then this angle would be 22.5. So you're just, the side cuts in half, the apothem doesn't, the radius doesn't, but the central angle does, okay? So on this particular problem, there are 2 ways to go about finding A. In most of our problems, we're going to use this half of the central angle, and we're going to use SOHCAHTOA of some form. In this particular problem, you can get away without using SOHCAHTOA because you could do the Pythagorean theorem, 3.92 squared is a squared plus 1.5 squared, but that won't always work because we won't always know 2 sides. So I'm just going to go ahead and I'm going to use this 22.5, and I'm going to use opposite and adjacent. So I'm going to say the tangent of 22.5 is opposite over adjacent. This is a really good review for us of our SOHCAHTOA, which is going to be important, obviously, going forward. I'm going to divide both sides by tangent 22.5, and A is going to be about, and I need a calculator, unless I have this example. Let me see. Sorry. Okay, sorry about that. I had to go hunt for my son's calculator. All right, so we've got 1.5 divided by the tangent of 22.5. which is about 3.6. So I'm going to plug that in right there for my apothem, multiply that. I like to just leave that long decimal in the calculator. It kind of keeps me closer to my exact answer. And I'm just going to multiply the other things there. We round usually to the nearest tenth. This is 43.5 units squared. Okay, I'm going to do one more on this video, and then I'm going to make another video just because the longer these are, the harder they are to upload. So let me go ahead and do this one. So a regular nonagon, that's 9. If you forgot those, you might want to look those up, is inscribed in a circle with a radius 5 inches. Find the area of the regular nonagon to the nearest tenth. So we know area is 1/2 apothem times perimeter. On this one, they only gave us the radius. So again, this triangle that pulls out of the circle is critical. You need to memorize radius, radius, side, apothem, central angle. Like that just needs to be like second nature to you, okay? So if I'm drawing this one, all they told me was the radius. So the radius is 5. And if you feel like, oh no, I don't have enough information, always remember central angle, 360 divided by 9. So my central angle on this one is going to be 40, right? So this is 40 degrees, but then you're always going to cut this triangle in half. So 40 cut in half, this is 20, this is 5. This is my apothem, and then I'm going to teach you something, like a little trick. I call this S star, and if I was in class right now, I'd be making a really big deal out of this. I don't want to call it S because it's only half of that side that I need. So I call it S star. That way I remember every time I find S star, I just multiply it by 2 to get this entire side that I'll need to find my perimeter, okay? So on this one, we're going to use 2 trig functions. So first, I'll find the apothem. So this is adjacent, that's hypotenuse. So the cosine of 20 is a over 5. So just multiply both sides by 5, and a is about, we got 5 cosine 20. Make sure your calculators are in degree mode. Remember when you're doing SOHCAHTOA. So my apothem is about 4.7. And then opposite and hypotenuse for S star. So the sine of 20 is S star over 5. So 5 times the sine of 20. So S star is about 1.71, but I don't want that. I need S. So I'm going to times that by 2 and get about 3.42. I just try not, oops, sorry guys. I try not to round until closer to the end. All right, so A is 1/2. Remember, my apothem is about 4.7. Now my perimeter, this is a nonagon, so it's 9 sides of 3.42. And then you're just going to multiply it all together. Times 9 times 4.7 divided by 2, or times 0.5, and it's about 72.3. I think this one had inches squared. Actually, going back to this one, I think it had centimeters squared. Okay, so that's just page 1 and 2 of today's lesson.